Hello everyone. In this lecture, we are going to cover resolution of vector. Resolution of vector is very important topic in physics because many times we will see that there is a vector and we have to resolve a vector along two mutual perpendicular axis direction. That means it will be generally vector is given, you resolve a vector along x and y. Okay, that x and y axis is nothing but mutual perpendicular axis. Okay, so this topic we will cover in two parts. First one for 2D resolution of a vector in 2D, and second one is a resolution of a vector in 3D. That means 3D vector will be given. So in two parts, first one I will cover 2D part, second one I will cover 3D part. So first one is 2D part, 2D. So this is 2D. So in 2D a vector will be given in a plane. Plane means I will take here axis x and y. Okay, so this axis is x and this axis is y. Now this x and y is mutually perpendicular axis. So here a vector a is given. You have to resolve this vector along x and along y. So let's assume angle theta. This vector a is making angle theta with x axis. Okay, so here I will draw one perpendicular from vector A, and let's take this is O, this is A, and this perpendicular let's take this is B. Okay, so here AB is perpendicular on x-axis. Okay, this is vector A. Okay, so we have to resolve this vector along x and y. Okay, so let's say this value is OB value is this is along x-axis. So I will write here this is AX, means component of vector OA. OA means A. So component of vector A along x is AX. Component of vector A along y axis is AY. So I can write here this is I'm assuming theta. Okay, so this theta, this vector A is making with x axis. So here we can write this triangle OAB is right angle triangle. So in right angle triangle OAB, we can write here cos theta equal to base OB upon hypotenuse OA. Base AB length I am saying AX, and OA length is vector A length. Vector A length is A. So we can write here AX equal to A cos theta. Similarly, in same triangle, if I am writing sin theta, then I can write sin theta equal to perpendicular that is AB upon hypotenuse that is OA. So AB length is AY and OA length is A. So we can write here AY equal to A into sin theta. Okay, this AX and AY is known as rectangular component. And AX and AY is known as rectangular component, and this AX is, we will call it, this is x component of vector A. This one AY, we will also call it y component of vector A. Okay, so we can write vector A in two parts. In y axis we will write AY part, and x axis we will write AX part. Okay, so here we can write this vector A is we can write OB plus BA. OB is AX I cap, along OB length is AY, that is along J cap. We can write like this. This AX is A cos theta I cap, AY is A sin theta J cap. Okay, so we can also write in this form or in this form. Here AX and AY is component of vector A along x and y axis. Clear? So this is how a vector will be resolved in 2D axis. Okay, so I will give you one question based on it. This AX and AY is known as rectangular component. Okay, so I'm saying that there is a force. Let's take here, this is X and Y. I'm saying that there is a force of magnitude 10 Newton, and this makes an angle 30 degree with x-axis. So find component of force along x and y axis. So how will we solve it? Along x component will be fx, that would be f into cos theta, because this vector is f and this vector makes angle 30 degree with x-axis. So we can write here f cos theta. So this is f into cos 30. This value will be 10 into root 3 upon 2. So this is 5 root 3 Newton. If I am calculating here Fy, so Fy will be equal to F sin theta. This value will be 10 sin 30. This value will be 10 into 1 by 2. So this will be 5 into. So this is how we will resolve a vector along two mutual perpendicular axis direction. Let's take another question. I'm saying there is a particle which is moving, let's take here, with 20 meter per second, and this particle makes angle 37 degree with x-axis and this is y-axis. Find the velocity component. Find component. Find component of velocity along x and y. So along x and y, what is component of this velocity? So we can resolve here. Vx will be equal to 20 cos 37, and we know cos 37 value is 4 upon 5. So this value will be 5 4 is 4 into 4. This is 16 meter per second, and y component will be 20 sine 37. This value will be 23 upon 5. This value is 12 meter per second. So this is how we will resolve a vector along two mutual perpendicular axis direction. Let's take one more question based on inclined plane. I am saying that there is inclined plane, and on this inclined plane there is a mass here, mass. So weight will always act downward, mg. This mj is, let's take w, weight. Okay, so here given that this angle of inclination, this angle of inclination of this plane is theta. So component find component of weight along x and y. Sorry, not along x and y. We have to find component of weight along the plane, and perpendicular to the plane, okay. So along the plane and perpendicular to the plane. So this weight is acting downward. If this angle is theta, this angle will be of course 90 minus theta. Okay, this angle will be 90 minus theta. So this is w downward. I want to resolve here. So this, the resolution of this vector, this is a vector. So here it will be w cos w cos 90 minus theta. This is 90 minus theta. So which will be equal to w sin theta. And here if I am resolving perpendicular to the plane, this is perpendicular, this is perpendicular. So this is w sin 90 minus theta. This will be equal to w cos theta. So here answer is along the plane component, how much? We have to remember this value. This is very standard value. Along the plane w sin theta. If there is acceleration downward, g, so along the plane acceleration will be g sin theta. Perpendicular to the plane, g cos theta. Okay, so here perpendicular to the plane, perpendicular, this is, let me write perpendicular. So this is perpendicular to the plane. Perpendicular to the plane, component will be w cos theta. Okay, so if there is, simply if there is, let's take here any body is there and g is acting downward, gravitational acceleration downward. So what is component of acceleration along this? G sin theta. What is component of acceleration perpendicular to the plane? G cos theta. Okay, where theta is angle of this angle of inclination. So angle of inclination is given, then weight component along the plane will be weight sin theta, and perpendicular to the plane will be weight into cos theta. Okay, so this is how we have to resolve a vector into mutual perpendicular axis direction. Only you remember, if there is vector, so x component will be vector magnitude into cosine of angle between them, and y component will be vector magnitude into sine of angle between vector a and x axis. So this is theta, so component of this along x a cos, component of this along y a sin theta. That much you remember. Okay, so this is how we will resolve. So next, second one is for 3D. Okay, so second part is 3D vector. So this is 3D vector. So 3D vector means I will take here axis. This is x, this is y, this is z. Okay, so here I am taking a vector. Let me draw one keyword here. So this is, I am drawing here one keyword. So this is, okay. So now this is origin. This is origin. Let's take this origin is O. I am connecting here. I am connecting here O to this diagonal. This diagonal. This vector is, I am saying here vector A. This vector is vector A. Now this vector is 3D vector. Okay, so this vector will make angle with x-axis. X-axis it will make angle. I will give here name alpha. Angle, this vector is making angle with x-axis is alpha. This vector A is making angle with y-axis. That one I will call beta. And this axis will make angle with z-axis. I will call it gamma. Okay, so now I have to resolve this vector A along x, along y, along z. Okay, so here let me say that vector A magnitude is A. Okay, and this length up to this length I will call it AX, means from O to here up to this point. So let me say this is A point A, this is B point, and this is C point. So length of OA is AX, length of OA equal to AX, OB equal to AY, OC equal to AZ. Okay, here AX, AY, AZ is known as, again this is component of vector A along x, y, z. Here I will alpha equal to, this is angle between vector A and x axis. This beta is angle between vector A and y axis. This gamma is angle between vector A and z axis. Okay, so alpha, beta, gamma. AX, AY, AZ is component along x direction, y direction, z direction. So exactly the way I have written for 2D, A equal to AX I cap plus AY j cap. Similarly, I will write here also. Here this vector A will be equal to, this is AX I cap, AY j cap, and AZ k cap. This is 3D vector. Now what will be value of AX? AX value will be, I will write here, this is vector A. So length of vector A is nothing but A. Okay. So here AX will be equal to A cos alpha. AY will be equal to A sin, sorry, A cos beta, and AZ will be equal to A cos gamma. This is AX, AY, AZ. Okay, AX is A cos alpha, this is A cos beta, A cos gamma. Okay, so now we can write here vector A. We can write here vector A in terms of this one also, A cos alpha I cap, A cos beta j cap plus A cos gamma, this is k cap. Okay, so this is how we will write vector. So this is important here. Now value of ax, ay, az we can calculate here. Okay, here alpha, beta, gamma is angle between vector a and x axis, vector a and y axis, vector a and z axis. Okay, so here this cos alpha, cos beta, cos gamma is known as this. Cos alpha, cos alpha, cos gamma, cos beta, cos gamma is known as direction cosine, is known as direction cosine. So here component of vector we can calculate. Vector A is this one, direction cosine cos alpha, cos beta, cos gamma. So if I have to calculate magnitude of this vector, so to calculate magnitude of vector, we can calculate here. This is vector A magnitude. This will be equal to ax square, ay square, az square. This value will be equal to, we can write here. Uh, we can write here. This is a cos square alpha, a cos square beta, a cos square gamma, and we will see later on that this value will be cos square alpha plus cos square beta plus cos square gamma will be 1. So this is how we'll find out magnitude. So if and this value will be nothing but a. Okay. So now if I'm calculating unit vector along vector A, then I will call it A cap. This value will be vector A upon magnitude of vector. That means I can write here Ax I cap, Ay j cap, Az k cap upon magnitude is Ax square, Ay square plus Az square. So this is how we will find out unit vector. If there is 3D vector, if you want to find out unit vector along 3D vector, so only we have to write vector upon magnitude of that vector. Okay, so this is vector upon this is magnitude of vector. Okay, so this is unit vector. Now if they are asking, sometime you'll see that what is angle between vector A and x axis, that means they will ask alpha. So if you want to calculate alpha, so see exactly cos alpha, cos alpha is this one. So alpha you want to calculate, so you can write here, this is ax upon a. Similarly beta cos square ay upon a. Similarly gamma equal to cos inverse az upon a. So this is how we will calculate angle here. So angle we can calculate, unit vector we can calculate, magnitude of vector we can calculate, direction cosine is this one, cos alpha, cos beta, cos gamma. Here this is always true that square sum of direction cosine is always equal to 1. This always equal to 1. Okay, the square of sum of direction cosine is always equal to 1. And if I'm writing cos square alpha equal to 1 minus sin square alpha, then because cos square alpha will be cos square alpha plus sin square alpha is 1. So cos square alpha equal to 1 minus sin square alpha. Exactly we can write 1 minus sin square beta, 1 minus sin square gamma. So here 3 minus sin square alpha, sin square beta, sin square gamma. So we can write here directly. I am writing answer, this sin square alpha plus sin square beta, this sin square gamma, this will be equal to 3 minus 1, so it will be 2. Okay, so here this will be 2, this will be 1. This is known as direction cosine, and this is how we will resolve a vector. Okay, 3D vector. Okay, so based on it we will solve question. Okay, so there is space, we can solve here only one question. If a vector makes angle 60° with x and y axis, then find angle with z axis. So if there is a vector making angle with x and y 60 degree, so of course this value is this this 60 degree is nothing but alpha, and this is also beta because from x and y. So this is 60 degree. So we have to find out angle with z axis, that is gamma. So we know that cos square alpha cos square beta plus cos square gamma, that is equal to 1. So cos 60 square, this is 1 by cos 60 1 by 2 square 1 by 4. So 1 by 4 plus 1 by 4 plus cos square gamma, this value is 1. So we can write here cos square gamma, this cos square gamma, that is equal to 1 minus, we can write here 1 minus 1 by 2, this is, so this is 1 by 2. So this is cos square cos gamma equal to, we can write here plus minus 1 by root 2. So gamma will be equal to 45 degree or 135 degree. Okay, so this is how we can solve it. So one more question I will take. Okay, so this part is over. One more question I will take here. Okay, I'm saying that there is a vector. This vector A, there is a vector. Let's take 2i cap minus 3j cap plus, let's take here 3, 4. This will be then 5. So 3, 4, this is plus 5 cap. There is a vector. Okay. So here, whatever is possible question, all will cover in one question. Okay. So here, find first, find first component of vector along x, y, and z. Okay, so component of vector along x, y, z. That means we have to find out here ax. What is ax? This is ax. So this is 3. What is ay? That is minus 4. What is az? That is 5. So this is component of vector along x, y, z axis. Clear? Now second, we have to find out magnitude of vector. Magnitude of vector. That means we have to find out vector A mod. So this will be, we can calculate here vector A mod is nothing but square summation ax square, ay square, az square. This value will be 3 square plus minus 4 square. This is 5 square. So after solving, this is 2550. So 5 root 2. Okay. Third one, uh, direction cosine. Direction cosine. So direction cosine, if we have to find out, so direction cosine will be cos alpha. Cos alpha, you know, ax upon a. So already we have calculated ax is 3 and a is 5 root 2. Cos beta, direction cosine and angle. And angle with axis. Okay. So cos alpha is this much. So what is alpha? Alpha also we can find out cos inverse 3 upon 5 root 2. Cos beta ay upon a. This value will be ay is how much? Minus 4 upon 5 root 2. So what is beta? Beta will be cos inverse minus 4 upon 5 root 2. What is cos gamma? Cos gamma is az upon a. This value is how much az? 5 upon 5 root 2. So this is 1 upon root 2. So what is gamma? Cos inverse 1 upon root 2. Suppose this angle is 45. This one we can find out. Okay. So we can find out direction cosine as well as angle with axis. Next, we have to find out unit vector. Unit vector along vector A. So unit vector, that means A cap we have to find out. We know vector A upon magnitude of vector. So how much is A? That is 3 I cap minus 4 j cap plus 5 k cap upon what is magnitude, already we have calculated. So this is how we can calculate unit vector. Okay, so next we can find out this direction, sum of direction cosine, that will be always 1, we can calculate. Okay, and this is also 1. So unit vector, angle, magnitude, component of vector, all we can find out. Okay, so this is all about. Okay, so this topic is over, resolution of vector. Okay, thank you so much.